So we are going to study carboxylic acid. The carboxylic acid are shown like this: COOH. So here the functional group is your COOH. This is the alkyl group. So carboxylic group actually consists of a carboxyl group and a hydroxyl group. It consists of a carboxyl, the structure is like that, and to it is an R is attached. So this is the reason of it, which gives us acidic property. Okay, it loses this hydrogen, and that is why it is acidic in nature. Now, depending on the number of COH group in the compound, it could be your monobasic acid. We already have learned what is monobasic acid. That is which on dissociation, when a molecule of acid on dissociation gives one proton or combines with one molecule of any base, it is called as a monobasic acid. Dibasic acid. So here in case of a monobasic acid, organic monobasic acid, it has one COH group. Here it will have two COH group. Okay. Tribasic acid will have three COH group in one molecule of that acid. So on that basis it is been grouped. Now the monocarboxylic acid, this is monobasic carboxylic acid. I am talking about dibasic carboxylic acid. So the monobasic carboxylic acids are also called as your, it is also called as your fatty acids, as because they actually form the fats and oil. So they are also called as your fatty acids. They are constituents of fats and oils. Example is your palmitic acid given in your book. Next is the nomenclature. So according to the trivial name, the lower series, the compounds in the lower series, that is your HCOH, then CH3COH, they are named, their trivial name are given depending on their source. Now this is your trivial name is formic acid, as because this is present in ants, and ants in Latin are called as what is it called? It is called as formica. So hence the name is formic acid. Similarly, CH3COH, it is obtained from vinegar, and in Latin it is named as acetanum. Okay, so from there the name comes acetic acid, and it is called as your formica. So it is called as your formic acid. However, how the IUPAC nomenclature is given. So this is your methane. E we will not write. The E will be substituted with OIC, oic acid. This will be your ethan. E will be substituted with oic acid. Okay, ethanoic acid, methanoic acid. This way the names are being IUPAC nomenclature is been done. For example, this is your 4 carbon, so it is your butanoic acid. Now suppose it has got a branching, so it will be named as your, these two are isomers, branching is different here. So branch isomers are these. This is will be IUPAC nomenclature will be your 2 propan 2 methyl, sorry, it will be 2 methyl propan 1 oic acid. And what will be its trivial name? like it is N-U-N, its tribal name will be butyric acid and isobutyric acid. Okay, tribal name will be butyric acid and it will be isobutyric acid. Because of this carbon, it is called as isobutyric acid. So we got to understand that how it is named. So we have these as your suppose this one is given, so we have to, how we have to name, we have to number the longest carbon chain, and we have to give the carboxylic acid as number 1, and accordingly we have to give the IUPAC nomenclature. Select number done. For example, here it will be your 1, 2, 3, 4, 5, 6, 7. So this is your 2-methyl, 7 means heptanoic acid. Got it? So this is how the IUPAC nomenclature is done. We have to number the longest chain. Now next we will start with the preparation of carboxylic acid, and we will talk about acetic acid. It seems there has been hydrolysis of your ethyl acetate, okay, that is your CH3COO C2H5 plus water. So hydrolysis in presence of concentrated sulfuric acid, it gives you the acetic acid and alcohol. So I think preparation is not there in your syllabus. We will straight away learn the physical properties of your acetic acid. Acetic acid has a pungent odor. We have already, everyone has smelled vinegar at home. We know how the acetic acid smells. And when the pure acetic acid forms an ice-like solid on cooling, that is when it is cool, it forms an ice-like solid which is called as glacial acetic acid. Anhydric acetic acid on cooling below 16.5 degrees Celsius crystallizes out in the pure form, forming a crystalline mass resembling ice. Hence, pure acetic acid is also called as glacial acetic acid. So, acetic acid on cooling below 16.5 degrees Celsius, it forms ice-like structure, ice-like crystals. Okay, and therefore it is called as your glacial acetic acid. Next comes chemical properties. As we know, I have already told you that the hydroxylic hydrogen in this, the hydroxyl group here in the carboxylic group has an hydrogen which is actually responsible for the acidic nature. So when an acetic acid combines with an alkali, it gives the corresponding salt of the acetate and water. So it gives a neutralization reaction. For example, if we combine it with sodium hydroxide, it will form the corresponding salt, means sodium will combine with this acetate, and OH and H will combine to give you water. So you will get sodium acetate and H2O. Similarly, it undergoes reactions with other alkalis. So what you will get? You will get here CH3CO, 2 molecules of it, 2 calcium plus 2 H2O. So here we can see acetic acid is neutralized by alkalis, forming the corresponding salt and water. Next is with litmus paper. It turns blue litmus to red, as because it is acidic in nature. And its reaction with alcohol, already we have done it in alcohol. With alcohol, it undergoes esterification in presence of your concentrated sulfuric acid or dry HCl gas, that is C2H5OH. That is when alcohol combines with an acid, it forms C2H5O COCH3, that is your ester. This one is called as your ester. This functional group is called as your ester. So ethyl acetate is being formed. Ethyl acetate is formed. Okay, so it has got a very fruity smell, and actually this is a taste for your alcohol, or we can say that this is a taste for your acetic acid. It again, acetic acid also reacts with neutral FeCl3 and forms a red wine color, gives a red wine color PPT, which is also again a taste for your acetic acid. So this is esterification, and this reaction with ferric chloride are two taste for the presence of acetic acid. Next comes the uses of acetic acid. Obviously we know that acetic acid main use, it is used as vinegar for many food industries. It is very important, food industry. It is used as a solvent, it is used as a laboratory reagent, it is used as a coagulant. So these are the uses of your acetic acid. So this was our carboxylic group, where we have to remember what is the functional group in the carboxylic group. They could be monobasic, dibasic or tribasic depending on the number of carboxyl group in a compound. Then how they have been named, their trivial name. Then their IUPAC nomenclature, that is their end. In the alkane, the E is substituted with OIC, OIC group. That is E, the E of the alkane is substituted with this OIC acid, and their longest chain is numbered, and it is taken as a functional group. So it's numbered as 1, and accordingly the compound is been named. Then their chemical properties, the important is their neutralization reaction, then is the esterification reaction, as same as the esterification is same as shown by the alcohol also. We have done it in alcohol also. Okay, so this was there for the carboxylic acid.